Hello students, I am Mrs. Shreyasi Watve along with Dr. Manasi Kanetkar from PS Modern College of Engineering, Pune. Today I am going to discuss with you shift register. This is the topic from digital circuits. Reflection spots are added on slide number 4, 5 and 8. So let's see what do you mean by register. A group of flip-flop is called as a register. So to form n-bit register, we need to connect n number of flip-flops. Whatever data stored in a register that you can shift to the left, right is called as your shift register. So the bits stored in a register shifted when the clock pulse is applied to a register. So let's discuss what are the types of shift register. So first one is the serial in serial out, another one is serial in parallel out, next is parallel in serial out, parallel in parallel out, next is bidirectional shift register, and last one is the universal shift register. So let's discuss one by one. So before going ahead, let's see the movement of data in a shift register. So this is your serial in serial out but in a right manner. This is serial in serial out in a left manner. This is the parallel in and serial out. This is the serial in but parallelly out. Now next one is your parallel in and parallel out. Also whatever data stored in a register you can rotate to the right. Also you can rotate to the left. So student, please wait for few seconds and just think on which flip-flop is preferred for a shift register. So you will get an answer in the next slide. Yes, to design a register you need a D flip-flop. D stands for your delay or the data storage. So to design a serial in serial out shift register we need 4 D flip-flops which are connected in a serial manner. So the shift register allows serial input and produces the serial output. So here you can see the clock signal is common to all 4 flip-flops which is called as your synchronized clock. So student, please wait for few seconds and just think on how many clock pulses are required to get the final output. So here your answer should be the 4 clock pulses are required to get the final output. Now next type is a serial in parallel out shift register. So again you need a 4 different flip-flops which are connected in a serial manner, but there is a serial input and it is a parallel out. So you need to check the output parallelly from all 4 flip-flops. So again your clock is common, so it is a synchronized clock and there is a clear input you can apply. By using this clear you can reset the flip-flops. Now let's discuss the another type which is your parallel in serial out shift register. So now for a parallel in serial out shift register you need a combination of your multiplexer and flip-flop. So multiplexer means what? This is your 2 AND gate and OR gate will act as a multiplexer here, and there is a control line which will do the loading operation as well as the shifting operation. So this upper line you can see where this is the input for each and every gate, 3 gates. So this is a 1, gate number 2 and gate number 3. And there are another inputs are provided to apply the input. So that's why for a loading operation gate number 1, 2 and 3 will be active. At the same time your gate number 4, 5 and 6 will become inactive because this is connected to the another control line which is the shifting line. So when you want to do the shifting operation, so already we have added the data here or we have loaded the data. So whatever data stored in a flip-flop that you want to shift it. So this output goes to your gate number 4. Again this output goes to gate number 5, gate number 6. So when you want to do the shifting operation, your gate number 4, 5 and 6 will be in active state, and that time gate number 1, 2 and 3 will be in a inactive state. So this is your parallel in serial out shift register. Now next one is your parallel in parallel out shift register, where you can see you can apply the input individually to each and every flip-flop and you have to take the output from each flip-flop. So this shift register allows parallel input and produces a parallel output. So student, again here clock is common. So can you think on how many clock pulses are required to get the final output? Yes, here within single clock pulse, your all flip-flops will work together and it gives the output because it is a parallel in and parallel out shift register. So now discuss the next is your bidirectional shift register. Now this shift register is capable of shifting the data either in a right or left. It is depending on the mode. So there is a one line which is used as a mode. So there is a right slash left bar. So here when mode is selected as a 1 or a high, data will be shifted toward the right direction. When mode is selected as 0, data will be shifted towards the left direction. So again this type of resistor contains D flip-flop and your multiplexer combination. So the data, so input data is connected to the two ends of your circuit depending on the mode selected. Selected only one gate is in an active state. So now again let's see, this is your for a right shift operation, gate number 1, your gate number 2, gate number 3 and gate number 4 will be in active state. That time your gate number 5, gate number 6, gate number 7 and gate number 8 will be in a inactive state. So 1, 2 and 3, 4 gates are used for a right shift operation. Yes. So your output of the first flip-flop goes to the input of the gate number 2. Here output of the flip-flop goes to the input of the gate number 3. Same for the gate number 4. So for a right shift operation, gate number 1, 2, 3 and 4 is active and that time 5, 6, 7, 8 are inactive. So it will do the right operation. Same there is a for a left shift operation, your gate number 5, one control line is connected to the left operation and now gate number 5, 6, 7 and 8 will be in a active state for a left shift operation. At the same time gate number 1, 2, 3 and 4 will be in a inactive state. So here you can just do the right shift as well as the left shift. So this resistor is called as your bidirectional shift resistor. Now come towards the last shift resistor, which is called as your universal shift resistor. So till now we had seen a different types of operation where there is a serial in, serial out, serial in, parallel out, parallel in, parallel out. So all these operations will be performed by a single resistor which is called as your universal shift resistor. So by using this resistor you can shift your data to the right, you can shift data to the left as well as you can do the parallel loading. So this universal shift resistor is a combination of bidirectional shift resistor and unidirectional shift resistor. So students, here we have discussed all types of shift resistor. Now come towards the end, that is what are the applications of shift resistor. Shift resistors are used for a temporary data storage. These resistors are also used for data transfer as well as data manipulation. So now when you want to convert your serial data to the parallel data, that time also we can prefer the shift resistor. Also we can convert our parallel data to the serial data. Now they are also used in communication lines where demultiplexing of a data line into a several parallel lines are required. So students, here we are discuss all types of shift resistors and applications of shift resistor. So please wait for few seconds and just think on it. Can we use shift resistor as a specific type of a counter? So answer is yes. Here is a ring counter and Johnson counter are the applications of shift resistor. So we'll discuss this ring counter and Johnson counter in the next video. Hope you understood all the concepts. So thank you.